so today we're going to look at some expressions with rational exponents. Basically, it just means that the exponent has like a fraction up there. You can treat these like a quadratic. If you don't know what that means, here, let me rewrite it for you. You can make it look like this: 4x to the 1/3 squared, that, minus 5x to the 1/3. Keep it blue, and that's the first power, minus 6. Okay, so it's basically 4 parentheses squared minus 5 parentheses to the first power minus 6. And if you plug in like a letter to represent that empty spot there, any other, you can choose X or P or any letter. Let's just call it P. 4P squared minus 5P minus what? 6. So technically, you're solving a quadratic, except the variables have a rational exponent. Okay, so simply put, the way you want to do this is just basically work on this and then replace the letter P with x to the 1/3. Let me show you what I mean. Okay, so if this was our problem, we would try to factor it out. There are different methods. I like to use this one. To use the x method, you always multiply the first number to the last number. 4 times -6 is -24, and you put it on top. Then you take the middle term, -5, and you put it on the bottom, and you basically choose two numbers that multiply into the top number, where the two exact same numbers or the factors add up to -5. Obviously, it's going to be -8 and +3. And then what you want to do, most of you will do something like this: 4p squared minus 8p plus 3p minus 6, and then you would factor by grouping it. 4p parentheses p minus 2 plus 3 parentheses p minus 2, and you notice you can factor this out as 4p plus 3 parentheses p minus 2 equals 0. Now when you solve for p, it'll look something like this. P equals -3/4, p equals 2, but remember our original equation is not p, is x to the 1/3. So what you want to do is basically take that middle term, x to the 1/3, and replace p with it. X to the 1/3 equals -3/4, x to the 1/3 equals 2. Now, if that's confusing, again, you can start off by saying this: let p equal x to the 1/3, okay? And then do the replacement afterwards. Now, if that's confusing, then it's over. No, I'm just kidding. I'm going to do another one, and hopefully I'll make it even more simpler, okay? But the idea is you're going to recognize this complexity like a quadratic, like 4x squared minus 5x minus 6. You can do that too. All right, now we're not done because we're solving for x. We have to isolate x by itself. To do that, we're going to cube both sides like this. And when you cube the top and bottom, that'll become -27 over 64. That's your first answer. And then for this one, if you cube both sides again, you'll get x equals 2 to the 3rd, which basically makes that into an 8. Now, you normally need to check it. And the only time you really need to check it is when you have like an even number fraction, like 1/2 or 4/2 or something like that. When it's a cube or a cube on the bottom, like a 3, it can handle negative numbers. So usually you don't need to check those. But if you're not sure, you can always plug it back in and check. Okay, so here it is. Again, notice that the denominator is a 5. It's an odd number. Odd number roots, you don't need to double check your answer key as long as you're doing everything correct. All right, so what are we going to do here? But notice that the numerator, this one is a 2 and this one is a 1. Again, very similar to a quadratic. Now, what I'm going to do for this one is not use p, because some of you might be just confused with that change of letter. I'm going to solve it like this: 2x squared plus x. Again, I'm not going to, you don't normally write 1, but that's x to the first power. And then I'm going to bring 3 to the left side, and now you have a quadratic. Okay, so this is basically 2x squared plus x minus 3 equals 0. And we're going to just factor this again. 2 times -3, -6. You take the middle term, which is 1, and you put it right here. and you choose two numbers that multiply into -6, but adds up to a 1. So 3, -2. 3 minus 2 is 1. 3 times -2 is -6. And then you do your whole factor by grouping once more, 2x squared plus 3x minus 2x plus 1. You're basically taking these two, putting it right here in place of the middle term, because 3x minus 2x is basically equal to x. All right, you're going to group them up and factor it out. So this will become x parenthesis 2x plus 3. Something doesn't seem right here. What is going on? Did I mess up? Let me see. 2 times -3 is -6. And 3 times -2, yeah, it looks right. But why isn't this working out? 2x squared plus 3x minus 2x. And x goes into 2x plus 3. And then, oh, I'm so dumb. This is a 3, and I put a what? A 1 there. Okay, so now again, if it doesn't work, if it doesn't factor out correctly, something is wrong. So that's what, threw me, gave me a clue that I either misplaced something or I factored it wrong. But I basically, I don't know why. Oh, I think I was thinking about this one while I was explaining everything. Okay, all right, now it factors out carefully. So minus parenthesis 2x plus 3 again. So if these two comes out exactly the same, you're on the right track. All right, if you factor 2x plus 3 out, you'll get 2x plus 3 parenthesis x minus 1. There's an invisible 1 right here, and that's what's left over. You solve for x, you'll get x is equal to -3/2. X is equal to 1, but again, we're not solving for this x, we're solving for this x right over here. You always take that middle term, x to the 1/5, and that's going to replace your letter x. Now, the reason why I don't like this method or this procedure is because the variables look too similar. Like if some mathematician were to look at this, they'll say, what are you doing? Okay, you just changed the variable. I mean, I'm sure they'll know that I did the switch here without letting anyone know, but using the same letters doesn't really help. Okay, and that's why using another letter to represent the one that you're trying to replace to make it easier is actually more wise. So here you can say something like let x equals what? X to the 1/3. But again, that really doesn't make sense, right? Anyways, you get the point. So I'm just going to use x just for right now, just to make it simple, just to show you that we're again converting this into a quadratic, something simple, something we know how to do, factor it out, and then at the end, don't forget to do the switch and solve for the original variable. Again, you're going to take this to the 5th power. So this will be x equals -3/2 to the 5th power, because you're going to raise this to the 5th power on both sides. -3 to the 5th power, 3 to the 4th power is 81. 81 times an extra 3, what is that? I just use my handy dandy calculator. 243 over to the 5th power is, I believe, 32. And there it is. There's your first answer. And the second one right over there, if you raise it to the 5th power, 1 to the 5th power is still 1. So that's your final answer. Okay. Well, we should check the answer key just in case, right? Let's see here. E. Okay, we're on the right track. All right, let's move into other types. Now, you should recognize that this is not quite the same as the other one. You're thinking, well, how do you know that? Well, first of all, notice that the numerator, the 3 and the 1, they're not doubled. Like if you double 1, you're supposed to get a 2, but now you have a 3. Second, notice the denominator, it's a even number, so it's a square root. Third, recognize that you only have 2 terms. This one plus what? That term. Anytime you have 2 terms, it's called a binomial. And binomials are very easy to factor as long as the factors are exactly what? The same. Let me illustrate. You have something like, where am I going to do this? Maybe I'll just do it like over here. let's say you have something like x squared plus x to the 7th, or I'll just put a, I don't know why I keep putting 7th, so let's say 8 and 9. The common factor is x squared, or the greatest common factor is x squared. You pull that out, and you have 8 plus 9, x to the 5th. Now the question is, how do we get this 5 right there? Well, it's basically 7 minus 2. And notice we always pull out the smaller of the two exponents. The smallest one is the greatest common factor. And the same thing goes for fractions. Okay, this one is a half. That one is a 3/2. 1/2 is a smaller one, so we're going to pull that one out and divide everything up here by this common factor, the greatest common factor. This divided by this, you'll get a what? A 1 plus that divided by that. 5 will always be there. What do you do with the exponents? 3/2 minus 1/2 gets you 2 over 2, which turns into a what? A 1. And by the way, the stuff inside here stays as x plus 4. Okay? All right, and you set this equal to what? 0. Now you have two factors equaling 0. This one and what? This one. When two factors, even though it's a big bracket, parenthesis times a bracket equals 0. You set each parenthesis or a bracket separately to 0 and solve. So we'll put this as x plus 4 to the 1/2 equals 0. And this one, if you simplify, let's just simplify the stuff inside here first. So you got 1 plus 5 times x plus 4 to the first power, and then 1 plus 5. And by the way, when a parenthesis has a 1 for their exponent, you can just distribute everything in and remove the parentheses. 5x plus 20, and then you have 21 plus 5x, and you set this equal to what? 0. Let me make that neater. 21 plus 5x equals 0, and then you just solve. 5x equals negative 21, x is equal to negative 21 over 5. And this one right here, if you square both sides, you'll still get a 0. Let me make that neater too. So you get x plus 4 equals 0, and then you have x equals negative what? Negative 4. Now again, you're not done, because I told you when it comes to higher and higher levels of math, the answers that you get must always be verified, especially when you work with square roots. Square roots are these types, okay? The ones with the denominator of with an even number, okay? With the even number index, you have to always plug it in to make sure it works. So if I plug in negative 4, this will become 0. Negative 4 plus 4 is 0. Negative 4 plus 4 is 0 equals what? 0. So check. This one works out. This one, negative 21 over 5, does not work if you plug it in. Let me show you. Negative 21 over 5 plus 4 to the 1/2. Well, what is that? Well, you get common denominator. You'll get negative 21 over 5 plus 20 over 5, and that'll become negative 1/5 to the 1/2. And notice, you cannot take the square root of a negative number. This 1/2 here, that's basically a square root. So anytime you have a square root of a negative number, you say there's no real solutions. Now, you can turn this into an imaginary, but we're not looking for imaginary solutions right now. So when you have this, you stop and say, nope, this is your extraneous, okay? Extraneous just means an extra answer that does not actually work, okay? Now, there's another observation I wanted to go into before I jump into the next one, is this. You'll notice that this, let's see, I already said that, right? I can't remember. Oh yeah, the number 3 on top, it should be double 1, because look, you see this 1 right here? If you double the 1, you get a what? A 2. If you, again, multiply by 2, you should get a what? 2. So whenever you have a 2, 1, and nothing, that's a quadratic. Here, you don't have that. You have a 3 and a 1. And so also, you only have two what? 2 terms. These guys have 3 terms. 1, 2, 3. And this one, 1, 2, and 1, 3. Okay, so when there's a trinomial, normally you'll have what you call a quadratic situation, and you try to solve it in that same fashion. All right, look at this one. Again, it looks so complicated, but notice you only have two terms. This guy plus what? That guy equaling 0. And then you realize there's a common factor. X squared minus 4, x squared minus 4. Now, don't jump and think, okay, I need to factor this right now. X plus 2, x minus 2. You can, but it'll just make things really complicated. This is where you need to decide, okay, maybe I should just keep it the way it is and do it later. So let's pull out the common factor, x squared minus 4 to the 1/3. That's the greatest common factor between 1/3 and 4/3. What's left behind? 8x squared. So this is x squared minus 4 to the 1/3. And this is 8x squared. That's your first one. And then from the second term, you just subtract 4/3 minus 1/3. You get 3/3, which makes it into x squared minus 4 to the first power equaling 0. Again, two major two factors equaling 0. This one times what? That one. So we're going to set each one equal to 0 here. All right, so let's take the first one, x squared minus 4 equals 0. Oops, that's the 1/3. But if you cube both sides, you'll still get a 0. So it would be x squared minus 4 equals what? 0. And again, I was tempted to bring the 4 to the other side and do the square root. I mean, you can. Just don't forget to put plus or what? Minus 2. But rather than do that, it's better to do this. Keep it there and go like this. X minus 2, x plus 2 equaling 0 until you get x equals 2 and negative what? 2. Do we need to check? Well, do we have a square root situation or an even root situation? No, it is a what? A cube root. And notice also that all the x's are squared. X squared, and x squared. Well, even if you have a negative number and you square it, you'll get a what? A positive. Again, these are things you have to think about as you do these types of problems. At your level, it might just be, oh, let me just get to the end, just go A to B linearly. But when you do these problems, you have to think more holistically, okay, or mathematically. All right, how about this one right here? I'm not done. So we have 8x squared plus x squared minus 4. And then we have 9x squared minus 4. And voila. You see, I was trying to say aha, and it came out as voila. I don't know why. It's because it's late and I want to go to sleep, but I'm here to help you. And I want some peanut butter too, actually. I'm craving peanut butter right now. Okay, so 3x minus 2, 3x plus 2, difference of squares. X is equal to 2/3, x is equal to negative 2/3, and you have now 4 solutions. Okay? All right, so that's it for that one. Let's move on to some other stuff. There's about maybe, I don't know, 1, 2, 3, 4, 5, 6 more. Okay, now these should be easy. Okay, if not, then I hope this will help. All right, now don't be tempted and think, okay, do I need to change this back into a square root situation like 16 square root, and this is to the third what? Power. You can. Actually, you can. But there is always a different way or a better way. Now, rather than do that, notice that 16, so I'm going to leave this here, 16 can be rewritten in two different ways. 4 squared equals what? 16. Or you can actually write it as 2 to the 4th power, which also equals what? 16. Now, either one will work, but the reason why I want to choose this one, or 4 squared, is because of this 2 on the denominator. It'll cancel out. So rather than writing 16, you're going to write 4 what? Squared. Now, anytime you have an exponent right next to another exponent, we say it like this: 4 squared raised to another 3/2 exponent or power to the power of 3/2. You multiply it. So 2 times 3/2. That's just basically the same thing as 2 times 3 over 2. You cancel out the 2 and you only have a 3 left. So technically, you can do that. So technically, I just keep repeating myself now. 4 to the 3rd power is 64, and that is your answer. How about this one? 64. There are again two ways to write this. 64 can be rewritten as 4 to the 3rd power or 8 squared. Now, which one do we want to use? Do you see what I'm saying? We want to use 4 cubed because it's going to cancel that 3 out right over there. So now, We don't want to work with negative exponents. So we want to turn this into a positive exponent. How? Well, basically, 64 to the negative 2/3 can be rewritten as 1 over parenthesis 64 to the positive 3 what? I'm sorry, positive 2/3. When you take something in the numerator with the negative exponent and just move it down to the excuse me, move it down to the denominator, the exponent will change signs. It doesn't, you don't switch it, you don't flip it. All you do is change signs. Let me repeat that. If you have something like this, 4 negative 2 over, let's say, p, you can rewrite this as 1 over p times 4 to the second power. Okay, you should know that. You can actually even bring the p up and write it as p to the negative 1 over 4 what? 4 squared. So remember, the question, your question might be, which one's right? All three are correct, okay? Meaning you are able to move numbers around as long as you're consistent with your sign changes. These three expressions are equivalent. So here again, we don't want to solve, like, unravel the answer by multiplying or taking the radical when there's a negative negative exponent. So we're going to move it down. Now it's positive. Now we're going to replace the 1 over 64. I'm sorry, we're going to replace 64 with 4 to the third power. Now what does that do with the 3's? It cancels out. You have now 1 over 4 what squared, which is basically 1 over 16. Okay. All right, now here, what do we do? Now this one looks so easy, but you can make so many mistakes. First of all, realize that even though there's two parentheses here, okay, we're trying to follow the whole like PEMDAS, parentheses, exponents, multiplication, division, whichever comes first, and addition, subtraction, whichever comes first. But here, even though you see a parenthesis, all the numbers inside the parentheses are being multiplied. Anytime you have a bunch of numbers being multiplied separated by a parenthesis, you can just immediately remove it. Let me repeat that. When you have a bunch of numbers, and yes, a bunch is a mathematical term. When you have several numbers that are being multiplied inside the parentheses, and there are other parentheses where with more numbers being multiplied, you can remove it. They're just all just factors. So you can write it like this: 3 dot x to the 2/5 dot 2 times x to the 1/2. Okay, that should make things much easier visibly. So what do? Well, 3 times 2 is 6. And then x to the 2/5 times x to the 1/5. What do you do with those exponents? You add it. 2/5 plus 1/2. You need to remember, when you're multiplying two exact same bases with different exponents, you add. When you have an exponent raised to another exponent, you multiply. Where was that example that I had somewhere? I can't remember. Okay, I'll just restate it then. Okay, when you have a number, like let's say 6 to the third power raised to the 7th power. Now, obviously, I just chose that on purpose so that nothing cancels out. Just to show you, it's basically 6 to the 3 times 2 over what? 7. You're not going to add. You only add when you have two common bases. What's a base? Base is the number underneath the exponent. So 2/5 is your power, it's your exponent. X is your base. 3 is the base. 3's exponent is a what? Is a 1. 2 is a base. 2's exponent is a what? A 1. And the only time you combine the exponent is when you're multiplying two of the exact same bases. For instance, if you multiply, let's say, 6 to the 3rd times 6 to the 4th, that's 6 to the what? 6 to the 7th. You're going to add, 3 plus 4. Got it? Okie dokie. So what's our answer? Well, what's basically 2/5 plus 1/2? Gotta get common denominator, so you gotta go 6x to the 10, 10, 4, 5. So 6x to the 9/10th power. Okay? All right. Now I'm not. You can check the answer. If I'm wrong, let me know, so I'll have to re-edit the video. Should I check? No, I don't want to check right now. I'll check. Okay, let's see. 15. So everything's good. I don't know if my voice came out because the noise canceling feature might think that I'm background noise. Okie dokie. So again, what do you see here? Multiplication. Now this looks awfully similar to something like with the plus, right? Something that looks like this. Two factors that are common being added, then you factor it out. This is not it. These are two factors simply being what? Multiplied. And what did I tell you? When the base is the same, x minus 1, x minus 1, x minus 1 is the base. You're multiplying two parentheses that are exactly the same with different exponents. All you have to do is add the exponents. 1/3 plus negative 1 what? Fourth, which will turn into 1/3 minus 1/4. Okay, did that make sense? Now, if you didn't see that, try this. Again, they're the exact same thing, so I can just replace it with P. I love P. It stands for peanut butter. Okay, so instead of x minus 1, I'm going to call it P. So both are the same, so we'll call it P. P times P. If you're multiplying P is your base, they're the same. You add the exponents. Okay, I'm gonna switch it back. X minus 1 to the 1/3 plus negative 1/4. So what's 1/3 minus 1/4? 1/3 minus 1/4. Common denominator is 12. So we got 4 minus 3, which is 1/12. So this is x minus 1 to the 1/12 power. Okay, so that's it. Last two. Okay, now again, these are really easy. Sometimes I convert this into something that looks like this: 8n to the 4th over 9y squared to the 1/3, and do the whole like switcheroo, turn 8 into 2 to the 3rd power, try to cancel out the 3, but then the n won't obviously cancel out. So this one I just do basic radical. What you want to do here first is to recognize this, that it's a cube root, not a square root, and you can split it like this: 8 cube root of n to the 4 all over square cube root of 9 cube root of y squared. Okay, so let's do it one at a time. Now again, what did I do? When numbers, and you can only do it when numbers that are being multiplied, again, they're all factors, you can give the radical to each separate factors instead of doing it all at once. Now again, let me repeat, you could only do that when numbers are being multiplied. If you try to do this when numbers are being added, like let's say you have something like, x plus 5 over, well, let's see, x plus something like x plus 5 over 7y, no, that's 7y squared, 7, all right, just 7x, okay? And this whole thing was, square rooted. You're thinking, oh yeah, let's just do this. Square root of x plus square root of 5 over square root of 7x. Wrong, okay? You cannot separate radicals when you have an addition or subtraction in your expression. Okie dokie. So here we go. What's the cube root of 8? You should know this. Cube root of 8 is 2. Why? 2 to the 3rd power is 8. Here we have 4 factors of 2 in a cube root. How many can come out? Well, you can group them into something like looks like this, like n times n times n with an extra what? N. These 3 can be grouped now and be brought out. So this is basically n cube root of what? N. All right, so the numerator is finished. But notice the denominator. You don't have enough factors to bring it out. You have 3 squared, or 3 times 3. So I'm just going to leave it. Well, you have to leave it. There's nothing you can do except, watch this. And notice the y squared. Okay. Actually, let me use a different color. Oops. Okay, let's use yellow. Cube root of 9 times cube root of y squared. Again, what am I doing? All right, the numerator's done, but the denominator, there's a problem. First of all, it's a cube root and you don't have enough 3's, right? 9 is only 3 times 3. If we had a 27, like 3 times 3 times 3, you can take the cube root easily. Secondly, we don't want to have radicals on the denominator. So what do? Remember, when mathematicians are stuck, they always utilize multiplying by the number what? 1. 1, you can use anything for 1 as long as it equals what? 1. Well, what one thing do we need? Well, we need basically an extra 3 on the bottom so that it'll become 27. So here, let's do this. Let me change this to like a red, like a pink color. Okay. And do that right here. I'm going to multiply this by cube root of 3. So that when I multiply this to this, it'll become cube root of 27. Cube root of 27 is just what? 3. And then for this guy, I need an extra y. So I'm going to give him an extra what? Y, so that this times this will turn into y cubed. Cube root of y cubed is simply a y. But we can't just leave it like that. We have to do the exact same thing on top. Cube root of 3 and cube root of y, because this has to equal what? A 1, because we're multiplying by the 1. But we're multiplying this fraction by 1. When you multiply anything by 1, nothing changes, even though it looks pretty complicated. So, all right, now watch this. If I multiply this to this to this, what do we get? You basically get cube root of 27, and that's equal to what? 3. So on the denominator, you have what? 3. Let me change that to that pink color to stay consistent. Okay. And then what about these two? I'm multiplying the denominators out first. These two will become, again, cube root of what? Y cubed, which becomes just y. Ta-da! Now we have no radicals on the denominator. What about the numerator? Numerator, just bring it all what? Together. These are all cubes, cube n, cube 3, cube y. So let's put them all inside one cube. 2n, cube root of n, 3, and y. Now you can rearrange the order, write it as 3ny. So this is your final what? Answer. Very colorful. All right, last one for tonight. Now I'm going to hit the sack. Now we have 4th root. So that means we need 4 of the same factors to what? To pull it out here. How do we do this? Well, so let's first split it up. We got 4th root of 48. Make that a little bit smaller. 4th root of 48 times the 4th root of x to the 6 all over the 4th root of 162, and then the 4th root of what? Of y. Okie dokie. So let's see, what do we do here? It's kind of jumbled up here. So let me bring this down. Let me kind of move it out of move. It's not moving. Okay. I will just rewrite it then. So let's make okay, so this is 4th root of 48 x to the 6 over 162 y. All right, so let's split up the fraction to 4th root of 48, 4th root of x to the 6, 4th root of 162, and 4th root of y. All right, so the numerator, let's see, 48. Let's start with this guy here. Now you can make a factor tree, which I know most people do. And most people will just start by doing like 2 divided by this, 2 divided by 2, and then you start doing all this stuff. I need a 4th root. Okay, a 4th root, a perfect 4th root. I'm sorry, 4th root. A perfect 4th power like this. Like I need something like 2 to the 4th power, or 3 to the what? 2 to the 4th is 16. 3 to the 4th power is 81. And my question is, will one of those work? Now I can keep on listing it out, but notice 81 is way bigger than what? 48. Now the question is, can 48 be divided by 16? Yes. 48 divided by 16 is 3. So I'm going to go like this. 16 times 3. Do you understand what I'm doing? I'm looking for a fourth root. I want one of the numbers inside here, because when you split up the 48, where one of them is a perfect to the fourth power, perfect fourth power. So 16 can be written as 2 to the fourth times 3. So basically, instead of writing fourth root of 48, here, let me, again, choose a different color. So instead of, okay, so this is the original problem that I'm trying to do, right? You know, what do you do? Well, I'm going to rewrite 48 as 2 to the fourth times what? Do you get it? All I did was rewrite that number into two numbers that multiply into 48. Or again, 2 to the fourth power is 16. Got it? Well, now we have 4 factors of 2. What can we do? We'll get 2 can come out. And now you have 2 fourth root of what? 3. So that is the simplified answer for fourth root of 48. Okay, all that work. So I'm going to write it right here. 2 fourth root of what? 3. Now what about this fellow right over here? Well, there are 6 x's. So 4 of them can be grouped. It'll be x to the fourth power. That can come out, as it were. And it'll be x, fourth root of x. And you have two x's left. And what about 162? Let's see. Let's try 81. 162 divided by 81. Oh, it works. So basically, 162 can be subdivided or split into 81 times 2. Well, 81 is I know, it looks like a perfect square, because square root of 81 is 9, but the fourth root of 81, so if I do this, fourth root of 81 times 2, the fourth root of 81 is, fourth root of 81, or 81 is basically 3 to the fourth power. So what comes out? A 3. What stays in? Fourth root of 2. So this one goes right here. 3 fourth root of 2 times, and guess what? The y simply can't come out. It just stays there. Finally, we're not even done, right? Because formality tells us we don't want radicals on the bottom. So what do we do? Yes, you're right. I've heard it. One of you saying multiply by the number what? Multiply by the number 1. Well, here, let me rewrite this on the side. So 2 fourth root of 3 times x fourth root of x squared all over 3 fourth root of 2 times fourth root of y. Okay, so I'm gonna, well, okay, fine. You know, let's just give it all of our heart here. So we're gonna turn this into a green color and turn this guy, oops, you can't see it, this guy into a yellow. Yeah, yellow's good. So fourth root of y. So now again, I'm going to multiply by the number what? 1. But what 1 do I need? Well, in order for the fourth root to disappear, how many extra 2's do we need? We have 1 here, so we need 3 more, right? 2 times 2 times 2, which is basically 8. Or this time I'm going to write it like this. I need, now I'm not going to mess with the 3. 3 is fine. 3 doesn't have a radical. I just want to get rid of the radical for this guy here. So I'm going to multiply with an extra 2 to the third power. Because 2 to the third times 2 will become 2 to the fourth. Fourth root of 2 to the fourth is simply what? 2. Does it make sense? And then secondly, what about this one? Fourth root. So I need how many 4's? 4 of them. 4 y times y times y times y times y. I have 1 y, so I need an extra 3 more. See it? Yes, you can do that. You're like, can I do that? Yes, as long as you do the same on the top, because you want to maintain the multiplicative, no wait, what am I saying? The identity property of multiplication. You're multiplying by the number 1. Okie dokie. So, all right. So what happens? 3 is gonna stay here. That times that, well, this is again 2 to the first power with 2 to the cube power inside fourth root. So this will become 2 to the fourth. Fourth root of 2 to the fourth becomes a 2. The radical is gone. Here you have y to the first power, y to the third power, it will become y to the fourth power. Fourth root of y fourth will become y. So the denominator is just 6y. What about the numerator? We'll just combine everything into one big, like, what do you call it? One big happy family. Just multiply the numbers on the outside with the numbers on the outside. So it'll be 2x. And then fourth root of whatever's inside stays inside. 3x squared, 8. Because 2 to the cube right here is 8. That's this one. And then y what? Cubed, and they all have to just stay inside. So 8 times 3 is 24. Yeah, you don't have enough. So let me just rewrite all of this with a gray color. 2x, fourth root of the 24, x squared y cubed over 6y. Finally. Yeah, I'll check the answers. That's the fourth root situation. We got fourth root 29. 29. Oh, I totally forgot. Totally forgot. You can cancel the 1 and the what? Well, it's because I saw the answer. Okay, so I totally forgot to do that. Don't forget to do that. You can always simplify the numbers on the outside. So the final answer is x, fourth root of 24, x squared y cubed over 3y, which is that guy. Now notice over here, the teacher said, fine, if you don't know what you're doing, you can leave your fourth radical on the bottom. So now you're thinking, oh, what do I do? Well, if you go all the way back here, this situation right here is right over here. Okay, before we did that whole multiplying by 1. Do you see it? Okay, 2x, fourth root of 3x squared, right? 3, fourth root of 2y. So, they just combine it. So, from what I can gather on the answer key, if you don't know how to get rid of the denominator, the teacher says just leave it alone, and she'll receive the answer. Okay. All right. So I gave you both ways. I guess you could have stopped right here, but either way, I did it right. Okay. All right. So I think that's it for our radicals. Wait. Not radicals. What is this? Rational exponents. Okay. Study hard, and I hope you do well on your tests. Have a wonderful night.